Alright, so in this video what we're going to do is I'm going to teach you how to log into the WebMO demo server, build simple diatomic molecule. We'll submit the molecule for single point calculation and then start a new job using previous geometry. So that's just kind of a quick punch list of the things that we're going to do here. So we can start by just doing a quick Google search for WebMO demo server. And what we're going to look for is this link right here, this WebMO login. This will bring you up to the page that you'll use to access this. The username and password are already kind of listed on the front page here. It's just guest and guest. And when you log in, you'll see that you're in the WebMO Job Manager, which is up here. We're going to start our calculation by clicking this tab up here that says New Job, and we're going to create a new job. Now in this example we're going to use a really simple molecule, dihydrogen, H2, and we're going to start with pretty simple distances between the two of them, so that way there's no confusion. You can kind of get a sense for how kind of easy this actually is. First thing we're going to do is we're going to build our molecule. So you want to look for the periodic table icon, which is right here. We'll click that. It automatically defaults to carbon. So you're going to want to set this to hydrogen. And we'll go ahead and click on the screen and just put a single hydrogen atom there. And we'll put another hydrogen atom there. And you can even click and drag if it helps you to visualize it, to show you that the two of these are connected. That's totally fine. Kind of looks like a little barbell. So before we submit this for calculation, we're going to adjust these two atoms so that they're at a specific distance between the two of them. So we'll click the Adjust tool, and we'll go ahead and click each of these atoms. And when you do that, you find out in the lower left-hand corner that it has a measurement between the two atoms. And right now, the way it's drawn, it's about 1.457 angstroms. That is a unit that's smaller than a picometer. So that is 1 times 10 to the minus 10 meters is sort of what we're talking about. That's the scale. In this example, we're going to go ahead and set the distance to 1 angstrom. In your project that you're going to work on, you're going to set it to a variety of different distances, but for now let's just set it to 1 so we know how to do that. So with these two atoms selected, I'm going to click this little barbell icon right here. It says adjust the bond length. We'll go ahead and click that, and in this example we're going to set this to 1.0 angstroms. Apply it, so that actually shrunk the distance between the two nuclei, and then we'll go ahead and click OK. Alright, so this is now set to 1.000 angstroms, and we'll go ahead and send this forward. So we'll click the lower right hand arrow, and now we have to pick a computational engine. The engine that we're going to use is software called Mopac, and this is the software that does all the calculating for us. It sits sort of up underneath WebMO. So with the radio button selected next to Mopac, go ahead and click the forward arrow. And this will bring up your Configure Mopac Job Options screen. Normally what happens is WebMO will just count up the number and type of atoms, and then it will kind of create a job name for you pretty easily. That's a pretty, there's not a lot of information that's provided here, so I tell students to give yourself a bit of information so you can actually find it on the server. So I'll say H2, we've set this to 1.0 angstroms, and I'll use my initials, JMC. I'm going to set the calculation to molecular energy, and I'm going to set the theory to PM7. Don't worry about charge and don't worry about multiplicity. Charge will be 0, multiplicity should be singlet. Click the forward arrow, and the calculation starts. So what's basically happening is when you send this calculation off, it's going to another computer on a different campus in the United States, and that computer is actually running the calculation for you, and then it sends the data back, and you can access the file right here. So it's highlighted. You'll notice under its status it says complete, and it took about 0.1 seconds for this calculation to run. So we'll go ahead and click this, and it doesn't look really any different than what it was to begin with, what you put into it, but that's okay. What you're looking for is you need to scroll down the page, and you're looking for, in this case, PM7 heat of formation. So when we take these two hydrogen nuclei and we set them 1.0 angstroms apart, the end result is the computer calculates out what the energy is, and in this case it says it's negative 6.32397 kcal per mole. So we write this number down, and we got it. We write that number down. That's the measured value that would be on our y-axis, and we have, so that's the dependent variable. The independent variable is what we've chosen, so this is 1.0 angstroms, and we're good. We've done our first data point, so we would write all this information down, and then eventually we could use it to construct a plot. All right, so so does this mean that if we want to run another single point calculation, let's say we want to change this to 1.1 angstroms, do I have to repeat this entire process all over again? Not really. All you need to do is, once you've collected your data, click this little button right here, new job using this geometry, and it takes your coordinates from the previous calculation that you've done and drags them forward into a brand new screen. The proof of that is if you measure the distance between the two of them, you see it's 1.0 angstrom. So this is the exact same molecule that was calculated in the previous calculation. All right, so now let's say we want to change this to 1.1 angstrom. So we'll go ahead and click this barbell again, and we'll change the value. Slide this over here, 1.1 angstroms, and click apply. And of course, the nuclei get a little bit further from each other. We'll go ahead and click this forward. Mopac. We'll change the name. Again, it's H2, but we'll change the name to 1.1 angstroms JMC. This is a molecular energy calculation. Our theory is still PM7. The charge should still be 0. Multiplicity should still be a singlet. If you are running these calculations and you find out that you have a charge or you have a multiplicity that's other than a singlet, chances are the molecule is probably drawn incorrectly, which in that case you're going to want to start from scratch and just redraw the molecule. That should hopefully alleviate a lot of that problem. We'll go ahead and click forward, and just like we saw in the previous problem, this was our previous calculation right here. Here's our new one. It's running and it's turned green, so it's actually good to go. Again, 1.1 seconds right there. And click it. And as I scroll down the page, again, my independent variable is my distance between the two nuclei. So 1.1, that's going to go on the x-axis. And my heat of formation is 12.01136 kcal per mole. So I'd write that value down. I encourage you to work alongside a partner or maybe even a group of people. Everybody will be assigned their own molecule to study, which means that your values are going to be different. Your energy values, your heat to formation values are going to be considerably different. They're going to vary from person to person. But the process is the exact same for all of the calculations that you do. So sitting alongside somebody else might actually be quite beneficial in trying to help you understand how to do all these different types of calculations. Well, there you have it. That's everything that you need to know. In this video, I showed you how to log into WebMO, the demo server, how to build a simple diatomic molecule, and then take that molecule and submit it for single point calculation, molecular energy calculation using the PM7 method, using Mopac. And then take the resulting geometry and submit it for a brand new calculation based on the previous geometry. Email me your questions, jcar@cac.edu, and I will try to get in touch with you as quick as I can. Thanks.